All right. Advent of Code 2024, Day 1. And this one is called Historian Hysteria. The chief historian is always present for the big Christmas sleigh launch, but nobody has seen him in months. Last anyone heard, he is visiting locations that are historically significant to the North Pole. A group of senior historians has asked you to accompany them. They check the places they think he was most likely to visit. All right, yeah, so we'll get the stars. Okay, you haven't even left yet, and the group of elvish senior historians has already hit a problem. Their list of locations to check is currently empty. Eventually, someone decides the best place to check first would be the chief historian's office. Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. Okay, I guess that's what we'll be doing this year. This seems to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Throughout the chief's office, the historically significant locations, HSLs, no, nothing there, are listed not by name but by a unique number called location ID. To make sure they don't miss anything, the historians split into two groups, each searching the office and trying to create their own complete list of location IDs. There's just one problem. By holding the two lists up side by side, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists. For example, blah, blah, blah. Okay. What do we need to do? Pair up the smallest number in the left list with the smallest number in the right list, and the second smallest with the second smallest, and so on. Okay. All right. So we need to sort. Yeah, just need to sort. Within each pair, figure out how apart the two numbers are, and you'll need to add up all of those distances. Oh, okay. So we just sort and do a diff. Abs diff. All right, let's get the puzzle input. Actually, I think my script automatically creates a get input 2024-1. All right, there's 1,000 lines. And the numbers are on the order of 10 to the 5th. Okay. Yeah, so now we should have an input directory. Good. All right. We do have lines. I can say aoclib read lines, but I think I have read numbers. That's read num records. That's different. All right, we'll just go with read lines. Oh, what was it called? 2024-01.text. And then we're going to split it into, let's take a look here. Oh, it's separated by multiple spaces. Looks like 3 spaces, grep-v, 1, 2, 3. Okay, so every line has 3 spaces in it. Okay, so we can just say numbers is a vec of I64 2s. Let's see, for a line in lines. Let left and right is equal to line dot split 1, 2, 3 dot map num parse I64 unwrap collect. No. Oh, you can't just tuple that, can you? I was hoping to be able to do. Oh, we can do a split once. Yeah. Let's do it that way. Left, right. And then we can parse them. Let left is equal to left parse I64 unwrap. And do the same thing for right. And then we can say let nums push left, right. And that'll be our numbers, self nums. Oh, right. There we go. And then we can just print out the number of numbers we got. Oops. self-nums len. And it is 1,000. Okay, and I think this is pretty straightforward. All we need to do is loop over all the numbers, add up all the distances, with all the differences. So this would be self-nums map pair 0 abs diff pair 1 sum. I probably have to tell it. Oh, really? That's not an iterator. Okay. Self-num iter. Yeah, can't infer the type. So I64. Now it doesn't like that. Oh, because I need to sum these guys up. Okay. So we're iterating over every entry, and this is a pair of I64s. We're mapping it into an abs diff, which should be, oh, a U64. Okay. There we go. All right, so we got a big number. Let's see if it's right. It's not the right answer. My answer is too high. We're adding up all the differences, right? What did I do wrong? This should have been super easy, right? Yeah, you know, pair of 0 and pair of 1. Oh, you're right. You're right. Thank you, Rayon. I got to sort. I even said that while I was reading. I said, oh, we just sort them? Okay, no problem. That means we need to do this differently. Let left list is vec new. Let right list is vec new. And we'll say left list push left and right list push right. Oh, these have to be mutable. And now we sort them. Left list sort, right list sort. And now we say self nums, can I do this? Extend left list iter zip right list iter. No. Oh, this is creating a tuple. So we have to map it to what we want. AB vec bang. No, just this AB. Will that work? It doesn't even compile. Oh, there we go. What am I missing? This goes to the zip, right? A is I64, B is I64. We want to dereference those. That closes the map. That closes the extend. Oh. Oops. There, that's better. Okay, and it's a different number. Let's see if the different number is better. Yay, that's the right answer. Thank you, Rain Paro. I totally muffed that. I think I would have figured it out eventually. Hopefully. I'd like to believe that I would. All right. So that was part 1. Git status. Yeah, git add cargo lock. Git add dot. Git commit -m 2024 day 1 part 1. And there we go. All right, so that was day 1 part 1. Let's see day 1 part 2. Your analysis only confirmed what everyone feared. The two lists of location IDs are indeed very different. Or are they? The historians can't agree on which group made the mistakes or how to read most of the chief's handwriting. But in the commotion, you notice an interesting detail. A lot of locations IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. Okay. This time you'll need to figure out exactly how often each number, let's get rid of that. from the left list appears in the right list. Calculate the total similarity score by adding up each number in the left list after multiplying it by the number of times that number appears in the right list. All right, the first number is 3. And it appears in the right list 3 times. So, okay, so we multiply 3 by 3. Okay. Second number in the left list is 4. It appears in the right list once. All right. Did we reuse numbers? Oh, here we go. Fifth number 3, so it's 9 again. And the last number is 3, so it's 9 again. Okay. And if it doesn't appear at all, it's 0. All right. Well, I mean, we can brute force it. There's probably a clever way to do it, but I can just brute force it. This now it's not useful to have them as pairs. For pair in self nums. Because I want to grab the left one. Yeah, and then look in the right one for that. So we can say let count is equal to self nums iter map pair filter map. Pair of 1 is equal to left. Well, filter map does a right. Filter map does a an option. Yeah, it has to return an option, and then we just count them, right? Oops. And then we just need to multiply, say score plus equals left times count. And then this is just score. Oops. All right, this is the brute force method. Cannot multiply I64 by usize. We got a number. And it went fast enough. I'm not going to worry about making it better. Okay, that's the right answer. Because you could just walk through the pairs one by one and then have a pointer for each one and then say, okay, here's a 3, because it's sorted. So you should be able to just walk them each side once. Filter should just work on its own. Yes, you're right. Yeah, if we do this, then we should be able to just do this, right? And it gives us the same answer, I believe. Yes. Yes. Okay. Yeah, thank you, Ryan. I don't know why I was thinking filter map, because I started with map and my brain was stuck on maps. Okay, so that's pretty good. I mean, it is kind of the brute force lazy way to do it, but it works. So I can't complain.